Hi there, welcome back. Today we are going to introduce something new. It is the quadratic functions. And as you can see here, our quadratic functions are of the form f of x is equal to ax squared plus bx plus c. During this series, we are going to get this one inside out, and we make sure that we cover what is you need to know to deal with all these type of equations. First, when we talk about the quadratic functions, we have three parts here. We have the first part. This is the quadratic part of it, okay? We call it the quadratic term. And if you look at this one, bx is just a linear function, right? Like the line part of it. And this one is the constant, okay? The constant term. To be able to call this type of functions a quadratic, it has to have the quadratic term, meaning that a must not be 0. So once we have that, we have our function. And during the beginning of this series, we are going to try to see how we can graph these in the xy coordinates, okay? And also, before I continue, I would like to say that these graphs are also called parabolas. We will have opportunity to discuss parabolas later, but for now, let's look at the function we have here. Now, if we look at the function here, we can see that in this particular one here, the curve, it is meeting the y-axis at this point here, 0, 2. And wherever it meets the y-axis, we call it the Y-intercept. We can find out that this is happening when x is equal to 0. And if you look at the functions here, when x is equal to 0, f of x is equal to c. That means the c part of it can be found equal to 2 in this situation. The other 2 points here are the points where y is equal to 0. When f of x is equal to 0 here, we can make all these 0. And this is where it is interesting. Then we will dive into solving the equation in that situation. That is another one. Another point we can see here that this function comes up to here and then changes. This is the minimum. If it is curved the other way around, it reaches a maximum. So if I come here, what time you think that f of x will reach the extremum? We have seen in the derivatives that what we need to do is to take the derivative of f of x. So f prime of x in this situation is equal to 2ax plus b. And we know that when the derivative is equal to 0, we can get 2ax plus b is equal to 0. Otherwise, x is equal to minus b over 2a. This is a line. This line is the axis of symmetry. This is how we found it. This one is like the middle here. So if you fold the other branch to the other side, they will overlap. Meaning that if we know one side of here, we can mirror it in the other side if we know the axis of symmetry. Very important. I'm planning to make this series very short, so this was just the introduction. And by the way, the point where it reaches the maximum and the minimum is called the vertex. In my next video, we are going to find the coordinate of the vertex. We know already x is equal to minus b over 2a. And then we can find the other parts of the vertex. Okay? For that, we are going to convert this one to another notation, which allows us to study these curves. Thank you, and see you on the next video.